Okay, good morning, guys, and welcome to Unite 2017. How are you feeling, by the way? Yay! All right. So my name is Daniil, and I'm an art lead on the Edge of Magic project. And today I want to talk about our character creation pipeline. But before I do that, I want to actually talk a little bit about the game itself. Because, we haven't released yet, and nobody outside of our office actually knows anything about the game. And let's see what Age of Magic is all about. So, Age of Magic is a game created for mobile devices, and considering the game mechanics, it is closer to the card battler. But instead of cards, the player has real heroes with their unique appearance and abilities. The player may collect and upgrade these heroes in the campaign, or PvP, or clan activities, or other modes that we will put in the game later on. And as the game is still in development, we would like to demonstrate it for you. And I have a little gameplay video with me, so let's, guys, watch it. What you just saw is a real gameplay captured using iPhone 6. And the cool thing about Unite is that you can play Age of Magic here. For that, you just need to come to our showcase stand and test our game out. So that's cool. OK. Today we will focus on how we create our characters. And as you may see, this is a multi-stage process that requires the involvement of many specialists. And I think we won't be able to cover all the details. There's just not enough time for it. But we'll try to talk about the most important things. As an introduction, I would like to show you some of our keystones. From the beginning of production, we knew that we will work with an entire new game universe and with a lot of characters involved. And one of our ambitious goals is to create a AAA graphics on the mobile platform. I know this goal is pretty ambitious, but we work really hard to achieve it. And we also use Unity 3D engine, as many of you guys here, I believe. And the last 2 points are my personal favorites. Of course, we have really stressful deadlines, and we have a really tiny team of people working on the game. So both of that gives a really critical hit to your mental health, but that's OK, I think. And the main challenge for us is the huge amount of art we need to create. In particular, we have to create 70 unique characters. And the process of creating one from scratch takes about 1.5 person month of work. And you may calculate how much it turns out in total. And at the very beginning, we knew that our pipeline will involve a close cooperation with outsourcers. And this applies some level of risk to the process of communication. For example, a concept art should be perfectly understandable for those who work outside of the main office. So let's start from the concept art. Different companies use this term a little differently, but today I will explain what we understand by concept art. It all starts with a task from the game designer. He provides all the basic information for us. Who is the character? What's his story and role in game? Also, what are the special abilities he has? Our game designer also includes some visual references to better explain to us how he sees the character. And this is actually really helpful because it allows us to start digging in the right direction. We start from the quick sketches, drawing right on top of the battle arena, and we try to work as fast as possible. And we are not focusing on little details here. The main aim is to find that precise image that our game designer had in mind and to synchronize our vision. We're not focusing here on the final version of the character. We just offer quick previews. And sometimes it takes a lot of variations of hero before we can get the idea of how he or she should look like. And for example, when we worked on a bug-looking mind controller shot, we had plenty of versions, but iteratively we came to a right image. Okay, so now we understand what our character looks like. What's next? How to establish a process so there would be a minimum corrections on our way to the final asset. We have noticed that most amount of problems appear in the transition from 2D sketch to a 3D version. The proportions go wrong, we lose the character's personality, the silhouette is not right, and so on. And this is really an old story, the reason of the art director's headache and a well-known deadline killer. Therefore, we added to our pipeline one more step, a 3D sketch. This is a quick draft sculpt created by the concept artist himself using ZBrush. And this is what the final model is based on regarding the proportions and silhouette. And I'll show you a bit more of how 3D sketch looks like. As you may see, this is a highly simplified model that is based on a small preview image. No tiny details here, no detailed textures. And here we work on a silhouette on the large and medium forms. And because this is still sketching, the design of hero is being refined compared to the previous stage. And we also can see how the character looks from various angles and decide if the idea works well. And sometimes we even colorize our sketches with just, a simple poly paint in ZBrush. The instruments we use to create our draft sculpt are not a secret. Every way of generation and mesh tweaking available in ZBrush will do. It could be Z-Spheres, Z-Sketch, Dynamesh, and etc. And the coolest thing about it is that having this kind of model, we can test it right in our build. Of course, we're not going to put in Unity all millions of polygons of our sculpt. ZBrush allows us to optimize the model from millions polygons to thousands in a couple of clicks. And it can be a decimation master, or if you need more accurate mesh, then Z-Remesher. But generally, you may use anything, even a standard reduce tool in Maya. Also, you may bake textures like a color map and normal map, and usually this is enough. And yeah, have a look at these horrific UVs here. Auto-mapping detected. But accuracy is not the crucial thing here. And voila, the character appears in our build. And here we can clearly see how the concept fits in our game world, and how this character looks with the other characters from his race. And for us, this is the way to make the clearest evaluation of a future character. If there are any problems, we see them straight away at the early stages, and before the long and expensive process of creating the final model begins. Please have a look. On your left, there is a 3D sketch, and on the right, the final model of our character, Helena. Yes, while in the process of production, we have refined some details, but please pay attention of how much alike those two assets look. Silhouette, proportions, colors, and the personality were carefully repeated in the final model. And the cool thing is that 3D Sketch appeared on the 5th day of work on this character. And the final model, after a month or so, but while this model was in production, we already had the understanding that this design will fit in well in our game, and that we can be almost 100% sure about the final result. One more demonstration of how close the draft sculpt lies with the final high poly mesh. And 3D Artist works right on top of this sculpt. And 3D Sketch saves us plenty of time and allows us to avoid a lot of mistakes and corrections on the stage of modeling. And sometimes we even prototype the animations using 3D sketches. To do so, we ought to make a quick rig. And to be honest, it's not even a rig, but more like a simple skeleton. No controllers, constraints, and complex systems, only joints, IK, and draft skin in here. And now we have the possibility to work on some animation prototypes. For example, let's look at this tank-class bug named Crushed. He has the ability to fold into an impenetrable armored structure. And this increases his armor, and the character that attacks Crushed gets the reverse damage. So this bug has to be able to fold, and when we created the 3D sketch, we made a test animation. We saw that the clamps and shell don't fit well together here, and this is definitely not what we wanted. We planned to make more monolithic structure. So as a result, we made the second iteration and corrected the draft sculpt. And as you may see now, the clamps and back perfectly fit together. And this particular sculpt was used in the 3D production stage. And now just imagine how painful it would be to discover this problem on the stage of a final animation. After all the past stages, that would be a real pain. 3D Sketch also allows us to see some unexpected problems with the design of the character. For example, this epic Archon, his name is Magnus, and have a look at his huge wings. Originally, we planned them to be always spread wide, but when we put this 3D sketch on the battle arena, we saw that these wings cover other units. And in some cases, it even happened when the wings were folded. And we came up with the solution. So let the wings be spread only during the attacks. And we even created a quick mock-up. Here is how it works now. And by the way, this very video was also a part of the final terms of reference for creating the VFX for Magnus. All right. Despite all our efforts, 3D Sketch doesn't provide all the information about the character's design. Many nuances of a costume, ornaments, or armor, small details, they either not presented here at all or made without any detailing. And for us, one of the most important goals is to provide maximum information to our outsourcers. Because, you know, fewer questions make it easier to work with. So we pose our model in ZBrush, render it, and make the overpaint to clarify some details. Such as colors, texture, material, and some nuances of a custom design. And we also use these sketches to show how this character's idle pose should look like. As a result, at the end of the concept art stage, we have the description of the character, 3D sketch, and detailed 2D version. Also, there could be additional things like test animations and storyboards. And you may think we're making things difficult, but this is not true. The practice proved that this set of materials will be the perfect terms of reference for those specialists who will work on this character after this. And this way, we minimize the production risks. And all the process of creating such concepts takes a bit more than a week. But at the same time, we specify many nuances, and it allows us to save weeks of corrections of possible mistakes. So here are some key things about 3D sketching that we consider to be a good experience. So 3D Sketch allows us to work with the quick iterations. It has a visual authenticity. And we can even prototype complex characters and animations using our 3D sketch. And of course, we are lowering the risks of working with outsourcers. OK, now let's talk about the 3D production of our game. 3D production starts with 3D sculpting, and most of the things I will tell you about are thought throughout the stage of sketching, but if the sculptor doesn't think about it while doing high poly, it's really easy to make a mistake. Of course, it's important that Sculpt transmits the stylization, plastic soft forms that had been laid down at the stage of concept. It's also very important to keep the personality of a character. In fact, the personality is the main thing in a character. For example, here, a mixture of a slight madness and stupidity are the distinctive features of this kobold. And I think this guy is also a cute one. It's also important to avoid the large amount of small details that could make the image too noisy. And at the stage of sculpting, we need to pay attention on symmetry of the model. And by that, I mean that we need to consider where it's better to use symmetry to save the UV space later on. One of the artistic principles we use is the classical approach to the composition of details. It consists of 3 levels. The first level is the large and recognizable shapes, and it's very important for the future character, especially when we watch him in a battle. The character is pretty small, and it's important that his forms are sharp and can be easily distinguished. But if you look closer, this is an area clear from too many details, and it gives a rest to your eyes. The second level consists of the medium-sized details, and they enrich the silhouette and image of a hero. And the third level is about the small details, and they make the character more interesting, gives him life, his own story. And they become perceptible if you look closer. And of course, they are very important in our character upgrade screen. And here's it. You may not only see the character in a large scale, you may also rotate him and look at him closely from every side. And we believe that players enjoy to have a close look at their heroes. And that's why we add up small details that makes the character more interesting. And we hope that in future, the players will want to cosplay our heroes. Why not? Besides the artistic principles, a 3D artist should consider the special requirements for modeling for the animations. For example, the knees and elbows should be slightly bent, and all the tails, ropes, braids, and etc., it all will hang down and bend and dangle. And in this stage, it should be straightened. And we use a standard A pose because it is pretty suitable for our animation rig. For example, one of the nuances that is really easy to overlook, for the correct setting of the IK, the arms of a figure should be straightened in a frontal plane. So what are our high polys consist of? 20+ million polygons, 50+ subtools, and it takes usually about 5 days of work. And what helps us? Of course, the outsourcing team helps. We use our own libraries of pre-built geometry, and we customize ZBrush settings according to our needs a lot. By the way, for example, here's an example of ZBrush customization. This plugin is called Z Scene Manager, and it really helps when you have to use many subtools. It's not free, but very useful. It looks more like an outliner in Maya than a standard Z subtool palette in ZBrush. So, guys, you have to definitely check this out. OK, now we go to the next stage, low poly. The most important at this stage is a maximal optimization, but preserving the visual quality at a high level. And how do we achieve it? Now, on this video, you see how our 3D production lead is examining the model sent to us by an outsourcer. He's looking at it from various angles and decides which edge we can get rid of and which one is better to be kept, which vertex is unnecessary and which adds to the quality of a silhouette. It is crucially important to watch the changing of a silhouette at this stage. For example, some edges are not visible if you look from the side, so it's possible not to model them, but it will be faked out by just normal maps. And of course, we use the classical optimization methods of low-poly modeling, and some of them you may see at this slide, and I believe many of them you guys may be familiar with. And let's not forget about the special requirements for future animation. We leave edge loops for bending of arms, legs, body, and etc. For example, one of the non-obvious things in low-poly mesh, if there's something sticking out of the body of your character, for example a spike, then it's highly recommended to put a vertex right below it. Therefore, after the skinning, the geometry will surely stay solid and won't slide. And it is especially obvious when you turn the textures on. OK, some more things about the project optimization. We have the one-sided shader, so all the one-sided surfaces will double with the flipped normals. And we don't use a transparency in shader. This is a quite expensive way of rendering on the mobile devices. And all the small details like holes in the cloth, mustache, feathers, they all are modeled, and this is actually much cheaper in terms of rendering. And the whole character consists of a combined mesh, including his weapon. All right, time for cute pictures here. After the model is ready and UV mapping is done, we bake the textures. These are the texture maps we get after baking. Some of them we use directly, for example, a normal map, but some of them we use as the additional ones to get such textures as a color map. For baking the textures, we use XNormal, and the process is quite simple. You get the high-poly model and the low-poly one, you upload them into the software, and it generates the maps for you. And talking about the texturing, I must say, sometimes we start the stage of texturing right after the finishing of a high-poly model, and it could be a classical poly paint in ZBrush. And here you may see this particular example, one of our characters, Tsuna, a foxy lady. And we keep the original textures in 4K resolution. We are doing so in case if we need to render the model for some promo materials in high res. But of course, in the game, we use the smaller versions of them. And here you may see the maps that supported by our custom shader. This set of textures we use for all geometry in the game. At the stage of low poly, we bake the occlusion right in vertices. You can see here these shaded parts like in the area under the hood, for example. The difference from the simple occlusion in textures is that it's reacting to the lighting, but it's very cheap as well. And now we see our main character, Roland, on a test stand. This stand is precisely set up with a neutral lighting. The battle arenas in our game are very different, and therefore it's very important to make the final setting of textures and shading in the neutral lighting. So then the character would look good at the different locations with the different weather and light. And here you see our different arenas. OK. Rigging. Rigging is a very important stage before the animation of a character. I will not talk too much about it, because it is a very big topic. At this slide, you may see some requirements that are applied to our animation rigs. For example, a limit of joints. For purpose of optimization, not more than 130 joints per model. And also, I would point out that our animators are not afraid to use their own scripts and instruments. And if you wish to save some time, you definitely should try scripting. Python, Mel, MaxScript, it's not as difficult as it may appear, and you shouldn't fear to avoid to learn these languages. Animation is a crucial stage. For our characters, we prepare idle, hit, death, base attack, and 2 or 3 special abilities. And all the attacks and the abilities may be divided in two types. Distant, the actions that the character performs staying at the same place. It could be throw, shot, or spellcast, and also it could be some effects that character applies on himself or his allies. And the second type, melee attacks, when the character moves, jumps to an enemy. And as you may notice, the enemies may stay at a different distance from each other. So the attacks may be shorter or longer. And why do we use jumps but not walking or running? During the playtests, we've discovered that players like when they press the button and get the immediate response. A sudden jump with a hit is just what is needed. And moreover, the jump is very convenient. It may be made to any distance. And as you see, the difference may be differ by 2 times. The character, if the character would have to walk or even run, it would make the gameplay too long, and the response for the player's actions would be delayed. And that is definitely not good for players' fun. For us, one of the most important things is to show the personality of a character in animations, something that differs him from all others. The special behavior of insect-like Roarachni, they are the giant bugs, and they act even like flies sometimes. Or if you look at Bilara, for example, she's a witch, and she has a completely different style of animation. Or our favorite fox Tsuna, well, she's a very cheerful character. And talking about the raccoon, we like him so much that we didn't want to kill him. Therefore, when he dies, he's just hiding in his book. And you will see it right now. Yeah, something like that. Most of the animation work we give to the outsourcers. And here you may see the different kinds of feedback that we give to them to explain our vision and ideas. And the last one, I think, deserves a special attention. One of the most effective ways to give the task to an animator is to make a video of yourself or somebody else. And here are some examples. So this is me doing really weird things with a huge stick in my hand. But I'm not that fat, actually. And here's a good action. Oh, this is our 3D production lead. And he's a real star, you know. I love this guy. Oh, yeah. This was a hot one. And the cool thing is that they pay me for this. All right. By the way, do you remember this guy? His name is The Last Keeper. And this is a giant battle machine from ancient times. And he is one of the bosses in our game. He alone fights a whole party of 5 characters. And now I will tell you how we created his epic death. Anton, our 3D lead, made quite a flexible rig for this guy, so that we can control all stones of his body. And from the very beginning, when we created this character, we thought that when he dies, he should literally fall apart. But the idea to break him up in big pieces seemed a little boring to us. So we wanted him to fall apart in smaller stones. So how did we make the process of his death? At the beginning, we did an animation and copied the last frame at a separate mesh. And then we cut that mesh in smaller pieces. We created the simulations of him falling apart. Then we used a Python script that created a separate joint for each part of the keeper. And then it copied the baked animation from our sim to that joint. Also, the script attached each part of a mesh to its joint, and then it combined all parts in one mesh. So the only thing we needed to make is to create one root joint and export the FBX into the game. Oh, that looks cool. In the game, when the animation of the keeper comes to the last shot, the mesh is switched to the one with all separate joints and the falling apart animation. And of course, we added some VFX. And we believe that such detailed simulation helps to bring more life to our animation and enrich it. And of course, the players like to watch something graciously disintegrating. Of course, things don't always go smoothly. Like a stone that hits this cobble's head, we get our own mistakes and unexpected challenges. And I will tell you about some mistakes that we already faced while working on this project. At the start of our project, we chose the wrong scale, and the first assets were in centimeters. But fortunately, there were not many of them, and we swapped to meters early enough. And the first assets we corrected just in Unity with the scale factor. The problem of skinning in Unity. As you may see here, the wings of Magnus looks crumpled. And this happens because of the chosen optimization method, influence of 2 joints on one vertex. Now we're trying to solve this problem out and testing the influence of 4 joints per vertex. And we'll see how it goes. At the start of the project, it was meant to be quite dark and brutal, but during the pre-production, we decided to move towards more casual style. And because of this, we had to change some textures, make them less detailed and noisy. And it took us quite a lot of time, actually. And here you can see not a mistake, actually, but the evolution of our visual style. And on your right is what we came up to now. In conclusion, I would like to tell you about 3 important things that helps us. First one is really clear. We know all the stages of process, how long each of them take, and we have a working pipeline. The process is set up and moving. The second point is, well, it's very important to be open for feedback and critics, but at the same time, you need to understand that you can't satisfy everyone, and you shouldn't. It's important that the leads on your project have the clear understanding where we're going to. And the last one is try to avoid the classical trap. When you constantly rework one character, the quality of which you are not satisfied with. Sometimes you don't even understand what exactly needs to be changed, but you still keep changing it. It's much better to make one more character than another, and make a whole bunch of characters. And I'm telling you, the quality of the last one will be what we wanted to achieve. And then you will just have to pull the rest ones up to its level. And it's much quicker and more effective instead of changing only one asset all the time and not moving any forward. All right. And this is all I wanted to share with you today, guys. Thank you. And now I would like to introduce our programmer, Illia Goncharov, and he will tell his part of the talk here. So please welcome.
Okay. Hi, everyone. My name is Illia, and I will tell you how we bring our characters to life in Unity. First of all, let's take a look how the characters look from the technical point of view. Basically, except from artist data, like geometry and textures, we also need to have a shader that will be fast and have a decent quality of image, some in-game loading mechanisms, some game design data, like balance and upgrades, or etc., and actual game core and character abilities. Let's begin from our visual part. Most obvious and critical thing is size. Its influence on the battery level and the device heat is crucial. More things to render, more heat from device and power losses. Your users can be affected too, because nobody wants to wait for hours for a game to download or even update. This is kind of initial pack of the assets for our characters. Overall, we have about 80 megabytes per character, which as a result gives us 5 gigabytes for 70 of all of them. So it sounds pretty ugly. Fortunately, it's simple to resolve this by using just Unity standard tools. First thing, always compress your textures. On iOS, you can use PowerTC for non-transparent textures with power of 2 size. For transparent ones, if your target platform is iPhone 6 and higher, you can use ACTC. Otherwise, there is some techniques that compress your images without quality losses. For example, you can use alpha map and color map and mix them on the shader level. With Android, it's kind of tricky because we have a pile of devices with different GPUs. Main idea here is creating different build versions with different compression settings. Google Play will do filtering for you, just make sure you have the right version codes. Don't forget to use MIP maps for objects that change their position relative to the camera. It will reduce your GPU usages and texture noises. Here you can see the small difference between MIP maps in iPhone 6 and iPad Pro. That's why we actually have the different setting even for different devices on the same platform. We actually don't need bigger textures for iPhones that we use on iPad Pro. For animation, we're using Unity keyframe reduction. For sounds, it's Vorbis or MP3. But if you're trying to use MP3, you need to remember that it has some small delay at the start, around 20 or 30 milliseconds. And here we get the final results of using these standard tools. A full-tuned character will take around more than 10 times less space than an untuned one, which is pretty decent for standard tools that you're getting from the box. Few words about shading. Due to our target of having AAA graphic on the mobile, we had to write our own shader that gives us speed and quality that we need, because the Unity built-in shaders weren't good enough for us. We are using dynamic shadow maps for characters and arena objects, which allows us to cast shadows on themselves and the other objects on the scene. Softness is provided by filtering at the fragment shader level. For static objects, we're using our own static shadow maps or pre-bake it in Unity light maps. For VFXs, we have additional light source that doesn't cast shadows on the other object, but can interact with other ones to create these fancy effects like this, green lighting around the ball. Also, we have our own variation of global illumination. It gives the depth to the pictures, softens the shadows, and help us to well enter the character into our arenas. We don't use post-processing, but we're applying color grading on a shader level, which in combination with lighting settings give us ability to create different surroundings, like night, day, or rain even. We also have some space for more optimization. We can always reduce our shadow maps, remove anti-aliasing, or replace our fragment shader with vertex one. About data loading. This is approaches that we're currently using on the project to provide better user experience for our players. Main idea here is to manage all your resources in that way, so you don't need to continuously load big chunks of data on each frame or on transactions between scenes or menus. That's pretty much it for visual data. Let's get into game design. What about game design? Currently, we have 10K rows of table data, which describes in-game elements. It's characters, skills, upgrades, and etc. This is crucial to have work with them in some efficient way. For us, it's very important to have ability to separate all data from the engine. That's why we didn't use Unity components, because it's impossible to separate them from the Unity. Excel can create huge problems when you're dealing with a merging of versions, so we decided to move on the Google spreadsheets and continue with them. Let's take a brief look how our actual game core works. A little bit of retrospective. This is how we initially tried to implement on the early stages of the project, but none of them was good enough to proceed with. So how we solved this problem? During our internal playtest, we created kind of wish list of things that we want to be able to do or have in our game logic system. First of all, our characters must be unique. We must have party synergy, so you can create some unique party and use your own strategy to win our game. We need to be able to create balance updates fast and in an easy way. Upgrades should have decent effect on a gameplay quality and the new character after release. This wishlist was reworked to create actual requirements for our development team to implement. It's obvious that the system must be extendable, because you don't want to bind your game designers, at least in some reasonable limits. Your logic must be stable, because you need to have ability to add some new mechanics or abilities without breaking any old ones. We need to use only domain entities to create skills like hit points, levels, rarities, or some upgrade values. We don't want that our code will be dependent on some character logic. This is very bad in terms of general design of the application. We also need to have ability to update our game design data and balance on fly. So in case we have some problems with balance, we can fix it right away without updating a version through the App Store or Google Play. And it must be executed separately from the game engine. So it's kind of must be like library file, so you can run it on your server or like test suite to check your balance values. And it's obvious that we can be integrated into game systems like animation, VFX, and sound. So if it works, but not in a good way, it's kind of very bad. After some researching and prototyping, we decided to create our own domain-specific language, as it was the only option that was able to satisfy our all requirements. That's why we can use only in-game entities, which make our code simple to read for our game designers and even give us them ability to implement character logic by themselves. And also, you don't need to deal with Unity subsystem directly. We have a simple way to pass out events into game engine for playing some sounds on hits or casting animations. It's time for some fancy examples. This is Last Guardian ray-based attack that triggers hits on the opponents. Or here you can see how we can add some randomness into Rogar's sizzling-like effect to improve our visual. So how it's look like in total. Here we have our model. It's simple C# classes that filled in with values from our Google Doc tables. All our DSL scripts go through this parser and transform into some inner tree for our virtual machine. We also use some additional things that provided by Unity MathF, for example, or some .NET standard things like math functions, enums, and etc. All these things goes into a virtual machine, which creates arena cycles. Basically, it's one combat between one party and the second one party. The result of this arena cycle can be passed into some external environment. It can be the Unity, if it's actual game, or our test suite for game designers, so they can check all the fixes of balance that they made previous. OK, so what about time? On the current project stage, the number is 4 months of development. So one man developed around 4 months. Someone can say that it's a lot, but we're using this system more than 6 months without any changes, and will not have problems for adding 35 more characters in our game without changing the game core. So this is pretty much it. Thank you for your attention. I believe we have around 5 minutes, so if you want to ask one question, you can, actually. Oops. Nope. No questions? Somebody? No?
Crystal clear.
Oh, yeah.
Oh, yeah. One.
How you manage it?
And can you repeat? Yeah.
OK. So first question about texture size. One compressed PVRTC texture weighs 1 megabyte, as far as I remember. How you managed to go below that?
We actually don't have a target to compress all our textures into a smaller thing that we can approach, but we have kind of want to try to find some middle way between the absolute smaller textures that we can achieve and the quality that we need. The final word in this is actually leading us to our art lead, so we can save our visual part. So there is no target to reduce sizes even less than 1 megabyte. Thank you for the question. No, yes. Just a microphone.
Hello. First of all, congratulations for the presentation. I really enjoyed it.
Thank you.
Thank you.
I have a question for the lead artist. The character pipeline looks very well developed, at least for me. How much time did it take for you to reach this detailed development for the pipeline of the characters?
Well, we had 3 months of pre-production, so we have this time to create our pipeline, to set some processes, and yeah, that's it. I think 3 months is the time you're asking. But you always have to keep in mind that the pipeline is not a stable thing. It always evolving, you know, and I cannot tell you that we have a solid pipeline. We're always changing it. It's little tiny changes, but it happens. So.
Anyway, it looks quite detailed, and I'm a lead artist also, and my production times are a lot shorter than yours. So I was curious just to see more or less how much time it took for you guys to reach such a developed stage for the characters production. But yeah, 3 months sounds good. Thank you very much.
You have to have this time, actually, because it's really crucial. It saves your time of production.
You risk a lot for the future processes.
Okay.
Thank you.
Thank you.
Keith, thank you. I believe that's all. So we need to have next team to check in. You can always find us on our stand on the showcase, so you can play our game or ask more questions. Thanks a lot, guys.
So thanks for coming, guys. And have a good day.